When you're finding eigenvectors and eigenvalues of a 2 by 2 matrix, there's something you can do to make the process go quicker. This came up in discussion today, and I wanted to discuss it with everybody. So let's let A be a 2 by 2 matrix. And suppose that we solved the characteristic equation determinant A minus lambda I equals 0 for lambda. Then to solve A minus lambda I V equals 0 for V, we can just erase one of the two equations. That is, no row operations are necessary. And the reason is that since determinant of A minus lambda I equals 0, so that's how we got here in the first place, the matrix A minus lambda I is not invertible. So that means it has rank less than 2. So that's 0 or 1. Now the only rank 0 matrix is the 0 matrix. So if this is a system of equations you're solving, of course you can erase the second line. Now if you don't have an all 0 matrix, that means that you have a rank 1 matrix. And that means that the second row is a multiple of the first row. And if the second row is a multiple of the first row, well, it's basically the same equation twice. You only need to look at one of them. All right, so let's do an example. Let's do exactly the example that I was doing in discussion today. So the example is A equals 2, 1, 3, negative 2. So determinant A minus lambda I equals 0 is determinant of 2 minus lambda, negative 2 minus lambda on the diagonal, 1, 3, equals 0. And that is 2 minus lambda times negative 2 minus lambda minus 3 equals 0. And that is, let's see, negative 4 minus 2 lambda plus 2 lambda plus lambda squared minus 3 equals 0. So in other words, lambda squared, negative 2 lambda and 2 lambda cancel each other out. Lambda squared minus 7 equals 0. So lambda is plus or minus 7. Oops, sorry, plus or minus square root of 7. So now if we look at the plus 7 eigenspace, so we'll solve a minus root 7I v equals 0. So we've got 2 minus root 7, 1, 3, negative 2 minus root 7, v1, v2 equals 0. Now we can't see by looking at these two equations, but one of them is a multiple of the other. So we can just look at the first equation. If we just look at the first equation, that says 2 minus root 7 v1 plus 1 times v2 equals 0. Or in other words, v2 equals, subtracting this, we have negative 2 plus root 7 v1. So the eigenspace, the root 7 eigenspace, is, let's see, we can let v1 be t, and then v2 will be negative 2 plus root 7 t, as t varies over all real numbers. So a basis is, if we just let t be 1, we've got 1 negative 2 plus root 7. Alright, so what if we looked at just the second row instead of the first? Because we could forget about either row. So alternatively, let's look at the second row instead of the first. So we have 3 v1 minus, I could say plus negative 2 minus root 7 v2 equals 0. That's the same as saying 3 v1 equals negative 2 minus root 7 v2, which is 2 plus root 7 v2. So we get it as a root 7 eigenspace. We can let v2 be 1, be t, and, oh, let me divide by 3. So v1 equals 2 plus root 7 over 3 v2. Then if we let v2 be t, we have t times 2 plus root 7 over 3 and t. I'm going to put the t afterward. And then a basis is 1 and 2 plus root 7 over 3. Now that looks All right, excuse me. V1 is this times V2, then V2 is t. And V1 is 2 plus root 7 over 3t. So in the basis, I've got this backwards. 2 plus root 7 over 3 and 1. All right, now that looks a lot different than the basis before. In fact, so different that we might be nervous that one of these is incorrect. But we can show that this is actually a multiple of that one. Therefore, the one-dimensional space can be spanned by either. So let's multiply this by 3 over 2 plus root 7 to get a 1 in the first component. So multiply by 3 over 2 plus root 7. So we've got 2 plus root 7 over 3 times 3 over 2 plus root 7, and 1 times 3 over 2 plus root 7. So we definitely get 1 in the first component, and then 3 over 2 plus root 7 in the second component. All right, it still doesn't look exactly like minus 2 plus root 7, but let's see that this bottom component actually is minus 2 plus root 7. 3 over 2 plus root 7 times 2 minus root 7 over 2 minus root 7. I'm doing that to rationalize the denominator. Gives us 6 minus 3 root 7 on top, and 4 minus 2 root 7 plus 2 root 7, those cancel, minus 7 on the bottom, which is 3 times 2 minus root 7 on the top, and minus 3 on the bottom. So that equals minus 2 plus root 7. So this bottom fraction with the root 7 in the denominator actually is equal to negative 2 plus root 7. So these are two bases for the same space. The end.